Good afternoon, everyone. We are students from EE third year, and today we are going to discuss on the topic about the binomial discrete distribution for the subject of engineering statistics. And my name is Yung Jian. My metric number is 178950.
My name is Wei Chun. My stroke number is 176586.
My name is Xin Qipei, and my metric number is 176946.
Hi everyone, my name is Derek Zhu. My metric number is 179614.
Now we are going to start on the first topic, is introduction about this binomial discrete distribution.
Now I will talk about the introduction of the binomial discrete distribution. So, in the probability theory and statistics, the binomial distribution with parameter n and p is the discrete probability distribution of the number of success in a sequence of n independent yes or no experiment. The n means that how many times the yes or no experiment is repeated, and the p means the probability of the success for the success. So now I will talk about the binomial distribution, describe the behavior of a count variable x if the following condition is applied. So the first condition is the number of observation n is fixed. So like just now I mentioned, the yes or no experiment is repeated n times. So this is but the n times we have to fix before start the experiment. Then second, each of the observation is independent. Means that each of the observation cannot affect the following observation. All the observations should be independent. Then next is each observation represents one of two outcomes. Means there is only yes or no, or success or failure. Next. And the probability of success P is same for each outcome. Means in the observation we are repeated for n times. Every time the probability for success P is the same. So then so this is a polynomial distribution. For a success or failed experiment, which with n equals to 1 is called Bernoulli experiment. The Bernoulli experiment is actually the basic of a binomial distribution. Besides that, the binomial distribution is frequently used to model the number of success in a sample of size drawn with replacement from a population of the size. So, if the sample is carried out without the replacement, that is not a polynomial, because without the replacement, there is not an independent observation. So, with the sampling that carried out without replacement, is called a hypergeometric distribution. So we need to clarify between the binomial distribution and the hypergeometric distribution. So have to remember these four conditions have to fulfill for a binomial distribution.
And now I will continue our presentations for the examples on the topic of binomial discrete distribution. And I've prepared one example here. The example is about the flower, and now I'm reading the questions here for all of you. Cross-fertilizing a red and a white flower produce red flowers 25% of the time. Now we cross-fertilize 5 pairs of red and white flowers and produce 5 offspring. 5 is the probability that there will be no red flower plants in the 5 offspring. So in these questions, as we read these questions, we know that this question is actually fulfill the conditions that have been discussed in the introduction just now. That is, there is a fixed number of the n, that is at here the n is actually equals to 5, and then each of the observation here is also have the equal chance of success, and also they are independent. And there is also only two outcomes, that is success and failure in these questions. And finally is probability of success is equal for each outcome. And then okay, let us look at these questions. How do we do these questions? First of all, we have to find the n first. The n at here is 5, and then we have to find the probability that is there is no reed flower. So we denote x is actually equals to reed flower. So at here, reed flower. So at here we have to find the probability where x is equal to 0, because we have to find the probability where there is no reed flower. So for these questions, the equations, actually we are applying the equations is using this one. What is this equation actually? This is actually the equation for the combinations. That is n factorial divided by r factorial bracket n minus r factorial. So we apply here. At here the n is actually equal to 5, and then the r is 0. Yes, 0. And then n minus r, so 5 minus 0 factorial. After that, we have to find the probability of success. The probability of success here is actually equals to p is equals to 0.25, and then the probability of failure is actually equals to failure. Let's denote the failure as f, so it's equal to 0.75. So that is 0.25, and then here is 0, and then here is 5. So this is actually the full equations for the probability where there is no reed flower. So what is, by using the scientific calculator, we got the answer for this is 0.237. That means there is 23.7% of 23.7% there is no reed flower among the offspring of the flower. So that's all for me. Thank you.
Hi everyone, so I will continue from Yongjian. So this is example 2. So in this example 2, the question is the probability that a student is accepted to a prestigious college is 0.3, which means the percentage of students enter the university successful is 0.3, which means p equal to 0.3. So in the other word, q will be 0.7, which means 1 minus p. And then if 5 students from the same school apply, what is the probability that at most 1 student are accepted and more than 3 students are accepted? So these are 2 sub questions. So to answer first question, at most 1 student are accepted. So first thing first, we denote x equal to number of students accepted. Okay, and then this is a formula to calculate the probability in binomial discrete distribution. So n is 5, x is 0 and 1, p is 0.3, q is 0.7. So by applying this formula, at most 1, so 0 and 1. By 3 to the power of 5. So this is the working procedures. So now I will use calculator. Okay, so for the first question, the answer is 052x522. So which means there are more than 50%, which is 53% that students will be accepted in the university at for the 0 and 1 student, which means at most 1 student are accepted. So to answer second question, more than 3 students are accepted means that if 5 students from same school apply, there are 4 students or 5 students. So P x equal to 4 more than 3, between P equal to x equal to 4 plus P equal to 5. So by using the same formula again, 5, 4, and then 0.3 to the power of 4, and then 0.7 to the power of 1, plus 5, C, 5, 0.3 to the power of 5, 0.7 to the power of 0. So, same as usual, I will use calculator. So the answer is 0.03078. So which means in 5 students from the same school apply, there are only 3% that more than 3 students are accepted in the school. So that's all for my example 2. Thank you.
So now I would like to talk about the application of binomial distribution. So the binomial distribution is often used in the quality control of the item manufacturing by a production line. When each item is classified as either is defective or non-defective. So in order to meet the requirements of the binomial distribution, the probability that an item should be equal to constant. So the condition is not met by sampling without replacement from a small batch, because in that case, the probability that the second item drawn will be effective depends on whether the first item drawn was effective or not, and so on. Then the condition of constant probability is met to an acceptable approximation if the total number of trial is much less than the batch size. So for a sufficiently small sample from a large enough batch, then the probability of a defect on a single trial will be approximately constant. Then the condition is met for sampling item by item from continuous production under a constant condition. It is also met for sampling for a small batch if each item which is removed as a specimen is returned to the batch and mixed truly with the other items. Once it has been examined and classified as defective or good. This, however, it is not often a practical procedure, because if we know that an item is defective, then we should not mix it with other item of production. Indeed, sometimes we can sometimes we can't, because the test procedure may destroy the sample. So that's all.